Do, 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 do. Okay, we're back with Iron Mario Chef here, and it's working okay. I made some changes to it. Functionally, you'll see no difference at all, but I wanted to talk about these changes. There are no new concepts in this video that weren't in the last video, besides enumerations that are not that complicated, and they're not technically a concept from this course. I thought they would neaten up the code so much that they're in here, and if you want to learn something about them, maybe even apply it in this course, you could. But it's just a nice way to basically, almost like mass naming a set of values, and they're integer values. It's just naming. I keep talking about avoiding literals. Like, I'm not going to write the number 7 in the middle of my body of code. I can assign a constant equal to 7 depending on what 7 is. 7 doesn't mean anything on its own. You can probably think of a lot of things that 7 could mean. Probably the most natural one, and pause if you want to guess at this, would be the number of days in a week. But 7 could mean a lot of things. It's a number. It can mean a lot of things. So like when you're writing a piece of code, normally you want that value to be named in your code. And part of what that means is, if you need that value in more than one place, you call it by that name. And if you want to change it, you only change it in one place. And if you think about a number like 7, and say you're writing some large enterprise system that includes a whole bunch of numbers, maybe it includes the ages of every user in the system for some reason. Maybe they're hard-coded. Maybe they don't come from a database. You can't go in and mass rename every instance of the number 7. You can't. You'll change a whole bunch of unrelated values. You might change a part of that system that someone else is working on. And so we identify every value that we can at least once. There's a philosophy related to this. Let me bring up a Wikipedia because I'm distracted now. I think it'll be a first match if I just Google dry programming. Dry programming. Check this out. Wikipedia has a page called Don't Repeat Yourself. This is a real thing. Let's check it out. It's a principle of software development aimed at reducing repetition of software patterns, replacing it with abstractions or using data normalization to avoid redundancy. Stated as the principle DRY, which is an initialism of do not repeat yourself. Well, I guess it's an acronym. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. That doesn't mean we take the number 7 and we name it SEVEN. That doesn't make any sense. But say we did have a bunch of individual users' ages, which is a bit of a strange thing to have in a system, but say we did. You might name it after each user and their age. You might say Kyle age equals 7. And then, anytime Kyle's age is referenced in the program, you just write Kyle's age. And that way, if that value changes, if that value is referenced somewhere else, first of all, you change it in one place. Second of all, it's easier to understand than writing the number 7. Because someone who's less familiar with that particular piece of code doesn't have any idea what 7's referring to. So, this is one of those reasons that I like to insist on using variables, using constants. Basically, we don't want numbers in our code. After our declarations, there's just no numbers. There's just no numbers. I'm not going to tell you every programmer ever stands by this, but I will tell you there are advantages to this, and it's a well-adopted software development principle. I didn't just make up that Wikipedia page, So I use enumerations for that in this case. But in the scope of what you're doing, the main thing you're looking for is you don't want arbitrary instances of numeric literals, even string literals. You might want to declare them as constants. But I'll show you enumerations as well. I used regions here, and so I've got 4 main regions as well as the initialize component call, which is basically it's the constructor of the form itself. And I've left that in there. It's outside the regions because it's not one of these other 4 categories. So I've got class level variable declarations. There's a lot of them now, a fair number. This does include a couple of constants. I decided I should, basically still adopting that dry programming principle, I've named day 0 and night 1 because I have to reference day and night in a couple places, and it's a random value between 0 and 1. I figured I may as well be unambiguous about it. I've adjusted things so that I have an array for each of the things that I randomize. Parts, game styles, and course styles. And so this has neatened up the code considerably. I've also got class level variable declarations. In some cases, they might only be used in one event handler, but I am kind of also planning future developments. And so I went ahead with this. I don't think it's a terrible thing. So basically, everything I store about the state of the randomized aspects of these Mario Maker courses is stored as an integer. So the game style, which is a random number representing, well, once it's stored, it's not random. It's the number representing the current randomized game style, the course style, the day or night, which is a value between 0 and 1. I mean, technically, you could store it as Boolean, but I haven't. I've just called it integer, which is sort of a consistency. I use these kinds of names. They're very, very unambiguous. It's very clear to another programmer what they mean, at least if they know anything about Mario Maker and this project in general. So I don't think any of the declarations are obscure. In my instance of the class library's random object, random class, my random value, I've just declared up there too because it is used in more than one place. So that's my variable declarations as well as some constants. Here's the new part, enumerations. If you struggle with understanding the part I'm about to introduce, don't worry about it because it's not technically in scope for this particular course anyway. So here's enumerations. I have 3 enumerations, so that's not too bad. And you can see kind of what I did here with these 2 lower ones. They're nice and simple. The game styles are listed there as enumerations. They're a little bit, they might come across as redundant with the array, but as we looked at back when I was writing this with if statements, there's certain parts that, for example, behave differently in Mario 1 and Mario 3 than they do in Mario World and Mario U. For example, if I used a shoe Goomba, this is something that will only mean something to Mario enthusiasts. Don't worry too much about that. The shoe Goomba only exists in these 2 game styles, and if you were to change the level to these 2 game styles, it would be a Yoshi egg, and so that's kind of weird. So when I'm printing out the parts, I sometimes need to check the game style, and the best way to do this is with a named constant representing that game style, rather than doing a whole bunch of weird string comparisons, which we did. I did have it that way originally. So there's some question as to whether you might consider this redundant or not. I think that when we see the actual code that does the randomization and especially the part that does the output, you will see this being used and you'll be able to appreciate it. I've done the same thing for course styles. It's got the 10 different course styles. And then here I have indexes for specific parts. This part's a little unusual, and I could technically list all of the 120 whatever parts, but I didn't. And the reason I didn't is because there's only some that vary depending on the game style, the course style, or the day-night status. It is kind of weird that there's at least one that does vary depending on the day and night status, because a one-up mushroom behaves like a rotten mushroom if it's nighttime. And I think it also hinges on a certain course style, at least that's my understanding. So the way enumerations work, if you care to know, enumeration means, you name this thing. It behaves a lot like a class, and that might not mean anything to you yet either. Don't worry about it, as I said. But it means I can call specific part.brickblock, and that will have a value of 1. And it's not an integer, but it can be cast to an integer. Spike trap, if I write specific part.spike trap, it's just like having a constant named specific part spike trap, and I can give it a value, and in this case I gave it 18. And so I only use the ones that I'm actually going to have as comparisons just to minimize the amount of code, but that's it. If I don't assign specific values to each element of an enumeration, they get default values, and the values are just assigned like a zero-based index. So you can actually see here in my IntelliSense, GameStyle.SuperMarioBros equals 0, GameStyle.SuperMarioBros3 equals 1, and so on. I even included Mario 3D World. We haven't implemented it yet, but I thought I may as well include it. That's the enumerations, and you'll see how that's used later. That doesn't do anything on its own. You'll see how it's used later. We initialize components, and we've got event handlers. There are only 3 event handlers, just as there were before. I have used a couple of functions, and so that kind of minimizes the amount of event handling code that exists here. So this is the randomize buttons click event, as you might be able to tell by the name or the description. I do have some future changes planned, by the way, and increasingly, the things I've done so far are designed with future changes in mind. So some of the decisions, if you think my decisions are bad, sometimes they are made with intent. That's not necessarily stupid intent. Some of it might be with stupid intent. You're allowed to disagree with me. Anyway, here we go. Check this out. Current game style equals get random index game styles. So my randomization function has been changed to, and you can see it because I highlighted it here. And when you highlight a function, or really any symbol in Visual Studio, if I highlight get random index, you'll see it like partially highlights, like it does this slight highlight on every other instance of get random index. So get random index is now a function that takes an array of strings and returns an integer. And the integer is equal to some random number between 0 and the length of the array. It's almost kind of weird that this isn't baked into the class library, but whatever. So this is going to set current game style equal to some arbitrary game style from the array of strings. And then I'm going to reference that array of strings to output it, but that happens later. I'm basically doing processing first, which is a thing you might remember from Prog 1205, depending who your Prog 1205 prof was. They might have really broken things down into input, processing, and output. In this case, there isn't really any input. Like, the only input is clicking the button. That might change later. We randomize the game style, or sorry, the game style here, the course style here, the exact same way. The primary part here. I still have a sort of, I guess you might call it a sanity check, where you don't want the primary part and the secondary part to be the same. And so actually, I guess there is a new concept, like a spin-off of an existing concept. This is a loop called a do-while loop. And it's a variant on a while loop, where the while statement happens at the end. So you write do, you open a brace, you write whatever statement you want it to loop, and then the condition that gets checked is checked at the end. The only difference between this do-while loop and an equivalent while loop, a while loop that has the exact same condition, is that it runs once before the condition is even checked. So if you want to run it 0 or more times, a while loop is a good idea. If you want to make sure you do it 1 or more times, a do-while loop is sometimes a little easier. And of course, you could write any do-while loop as a while loop. You just make sure you write one instance of the iterated code before the word do. This way I just thought was a little neater. And I get to show you something new. I don't think that's necessarily a terrible thing. So what this piece of code is doing in full is it's going to set the current secondary part equal to a random part. And it's going to keep doing that if the current primary part is equal to the current secondary part. And the way it's written, it's not like an if statement. It's not saying like, if these are the same, randomize it again, because of the very, very improbable possibility that it randomizes the secondary part equal to the primary part a second time. Which if there were 120 parts, you know, we're looking at, what did I do? We're looking at 120 squared there. I was going to calculate it out in the code, but I made a big mess instead. Let's use a calculator. That's what calculators are for. What do we, 123, I think? Yeah, a 1 in 15,000-ish chance of that possibility, but we can account for it in basically the same amount of code, so why not? And then we're doing the exact same thing with the band part. It would be nonsense if the band part was also a primary or secondary part. So it's the same thing. We randomize the band part, and we'll do it again if it happens to match the primary or secondary part. Besides the enumeration part, which isn't used yet, I hope nothing here seems unusual yet. This should be, and I've introduced little bits of new things, but this should be pretty easy to follow. I hope. It should be. Now comes the output. Here's the output. Okay. Set the game style equal to whatever the current game style is. It goes to the game style array, and it gets the current game style value for the integer, which is an integer. an integer between 0 and however many styles there are. Then we check if it's day or night, and based on whether it's day or night, and you can see here I've got my instance of my day constant. If it's day or night, if it's day, we output whatever the course style is and day. And if it's night, or if it's not day, I could say, then we output whatever the current course style is from the course style array at the index we've randomized, and it's adding in the word night. There's some question as to whether anyone would ever want to use that feature, honestly, because a lot of the nighttime styles are aggravating. Like the nighttime fortress, where it's like space but you swim, and especially the nighttime cave, the nighttime underground. It's awful. It turns the whole screen upside down, and I don't think anyone wants to play that ever. I guess someone does, because I see people playing them, but it's pretty bad. And then here at the end, we're going to call a function, and it says it sanitizes and outputs the random parts. The whole reason I have this somewhat silly function call, and I have it 3 times in a row for outputting parts. You can see it's a new function called output part. But that's that thing where it accounts for differences in parts between different game styles and course styles and day and night and so many things. So for example, there's the style-specific power-ups. They're different in all the different game styles. And things like the Master Sword, it's weird because it's not one of the style-specific power-ups that's equivalent in all the different game styles, but it only works in Super Mario Bros. 1. And so when the Master Sword is selected, we have to force the game style equals to Super Mario Bros. 1. So I did that in this function, and we'll see that below. So basically, this does the output. And at the end of this, it's all done. It's all randomized and output, and everything's great. Done. Perfect. Great. Happy. Reset hasn't changed at all. Exit hasn't changed at all. And that's the end of my event handlers. Then we've got 2 functions. It's a lot of code, actually, eh? How much is this? About 100, 160, this output parts function. Get random index became quite a bit simpler with what I did. And so you can see it takes in as a parameter an array of strings. It returns an integer. It declares the integer called random index. It assigns it whatever random value exists between 0 and the length of the array that's passed in. So this is the parameter array to randomize. And it says go to that parameter's length property and pull that number. So whatever length the array is that's passed in, that's the index we're going to use, and then we return it. So that's nice and simple. That got easier, right? But then this output part, it's a little bit bigger. And I didn't account for specific different part outputs in the last published version of this, I suppose, the one from the previous video, which was the 4th video. So this works differently now. Check this out. This has 2 parameters, and it doesn't have a return type. So all it does is it outputs something. It takes in a part and a text box. And what it does is it takes that part index and it finds means to output it as a string into whatever text box is passed in. There was some talk in week 4 about scope as it relates to methods. And at the end of that talk, we had a talk about the challenging to explain concept of by value and by reference and the ref keyword. And it's interesting because an argument passed into a function, usually it's a copy of it that can be changed. But because objects of a class are always reference types, any change we make to this output text box thing will actually get applied to the form. You might just need to trust me on that explanation because it's not an easy thing to talk about. It's not something it's not some big sticking point of this course. So for now, let's just say that's cool, right? That's cool. You can trust me. It works. All right. So in here, it's nothing. It's a lot of code, but there's not much in the way of complexity. It's a whole bunch of nested if statements, a whole big bunch of them. So check it out. This says if the part index is, and it gets the enumeration for specific parts, if it's a specific part brick block, and you can see when I hover over specific part.brick block, that's that value 1 from the enumeration up above. If you care about that. If you glossed over the enumeration part, I don't care because we're not using them in our course, really. This int thing force casts it to an integer. And since it's an integer value anyway, that works. So if the part index is equal to the integer value of a brick block, if it's a brick block, then we have to check, are we in the Super Mario World game style? So we get from the enumeration called game style, its Super Mario World value, which is 2. We make sure that 2 is treated as an integer. If game style is equal to 2, then instead of putting out brick block, we output rotating block. And again, this is something only the Mario fans would care about, but in the Super Mario World style, the brick blocks behave differently. They start spinning instead of being broken. Spike traps are an odd one. When they're underwater, and in the Mario 3 or Mario World style, they have a different name because they have a different kind of image. So they're electric jellyfish called Gelectro in the Mario 3 style. Sorry, the Mario 3 game style. So it checks. If the game style is Mario 3 and the course style is underwater, it's a Gelectro. If the game style is Mario World and the course style is underwater, it's a sea urchin. They look different. They do the exact same thing, but they look different and they're technically named differently. The style-specific power-ups, if you've been watching this whole series and you remember back to how, for example, the first model of this worked, it had a different piece of logic for how those style-specific power-ups were done. In one style it's a big mushroom, in the next style it's a super leaf, in the next style it's a cape feather, in the next one it's a propeller mushroom. And so here I've done it where I've used my enumeration to neatly figure out what the current game style is, and my output. In the output text box, whatever box is passed into this function, that's how I assign the value. And the value is a little bit hard-coded, I suppose. Technically, I could use I probably should use the specific part. Oh no, I can't do that because they all have different names in all the different styles. So I got to do it like this. But I do end up using the index later on. We'll see that. So yeah, this whole part it's a different power-up in each of the 4 styles that I support so far. And same thing with style-specific power-up too. So it's checking if the current game style is, you go to the game style, you look up Mario Bros, which is index 0, cast it to an integer. If the game style is 0, it's an SMB2 mushroom. If the current game style matches GameStyle.Super Mario Bros. 3, which is 1, cast that to an integer, so you have an integer 1. If current game style equals 1, it's a frog suit, and so on. And it's basically this kind of logic again and again in most cases. Here we have something different because there are 3 parts so far that are just legitimately, they're only supported in the original Mario Bros. Style, and there's no alternatives in the other style. And that's the Master Sword, the Super Ball Flower, and the Cursed Key. At least that's my understanding right now. Sometimes I forget things. And so what that does is, this one will actually force the current game style back to Mario Bros. It'll say, okay, you know what? We're not randomizing the game style. To support that power-up, we have to set it to 0. And then we have to output that game style. And so there's this certain number of cases where we force it to the Mario 1 style, which technically will make the Mario 1 style slightly more commonplace than the other styles, but that's really the best way to get this to work. They're the only cases where we have to do that, I believe. Shoe Goomba, in some cases it's the Yoshi Egg. I'm not going to explain the same thing again, but it's all here. This thing's named differently in one style. Goombas turn into Galoombas in Super Mario World. And snowballs. Spike balls are snowballs if you're in a snow level. That's what this is. This is a little different than the other ones. So these are all else if statements. They only are evaluated if the part index hasn't matched any of these so far. So it's going through and it's saying if the part index is, it starts up here. It goes, is it 46? No. Is it 51? No. Is it 52? No. Is it 68? No. And then it gets to the else. And it's like, if it hasn't matched any of these specified parts so far, if it doesn't match any one of them, then we just output it normally. We output whatever's in the array. And so that array is here. It's parts, just like it was in the previous video. And we're going to grab the index that's the current part index. And we're just going to output it into the text box. So no changes necessary. For the vast majority of parts, this is the part that happens. But for the other cases, we have to output it somewhat more manually in order to make it agree and not cause issues. As for what this does, how this works, it basically removes the possibility you might have seen if you watched the previous video. There was a little screen snip I took where there was Piranha Plant was both the primary part and the band part. And that's silly. So, oh, I just spotted an error. Well, I got a little debugging to do, but I can tell you this is close. Do you spot the error? The error is the Master Sword is one of those ones that's supposed to force the game style into Super Mario Bros. 1. Spike. We should also see they're not matching each other. I'm looking for any of those specific parts now. Make sure something there is working. I need to make this UI a little bigger. Oh, this is odd. My indexes might be slightly wrong. That's the only reasonable explanation. I wish I had this 100% right now. But I must have those manually set indexes a little bit incorrect, unfortunately. That one worked. This one doesn't. This is Shugoomba Yoshi Egg one has some kind of problem. So what I need to do is identify what index is Shugoomba Yoshi Egg. And I'll do that. There's still some debugging to do, but this is the state of it. I'll do that debugging, and perhaps I'll make this available to you at this juncture as well. An earlier version of this has been posted to our course. Anyway, you might make use of it, and our next big concept in this course, I suppose after version control, is two-dimensional arrays. And after that, we're getting into a little bit of object-oriented programming, and there's something good we can do with that. And then a little bit of advanced UI. I'm going to upgrade the UI a little bit. And we'll see what that looks like too. But that's all still to come. We'll see how much of that we can crank out in the next couple of weeks. Thanks for watching.